In section 9.5, we are studying angles and triangles, and so we have 5 sections to cover: to name an angle in 5 different ways and measure an angle with a protractor, classify an angle as right, straight, acute, or obtuse, and then find the measurement of a complement or a supplement of a given angle, and classify a triangle as equilateral, isosceles, or scalene, and as right, obtuse, or acute. And last, we given 2 of the angle measured of a triangle, find the third. So the first part is about measuring angles, and so there are some real-world applications of angles of the various types in the different back postures of the bicycle riders illustrated below. And in other words, what is their back relative to the road? So when someone is really into it, to create less drag, their back is almost parallel to the road. So that's about 180 degrees flat. Then when somebody sits up like this, again, here's the level of the road, and here's the back of the rider. And so on a mountain bike, people typically lean forward about 45 degrees. There's a 45-degree angle here. And then riding comfortably, sitting straight up, so we're not too concerned about speed. Then, this is a 90-degree angle here. Less stress on the lower back and neck. And so for different things that people want to do on their bikes. So here's some definitions and vocabulary words. So an angle is a set of points consisting of 2 rays, one way here and one way there, or half lines with a common endpoint. And that endpoint is B in this case. It's called the vertex of the angle. And the rays are called the sides of the angle. So be sure to remember the definition. This angle in the above illustration can be named in 5 ways. We can say angle ABC, or angle CBA, or using the symbol for the angle ABC, again the symbol for the angle CBA, or simply angle B. They're all equivalent. Now, for the first 4, note that the vertex is written in the middle of the name. And again, if there's only one angle with a given vertex in the drawing, then the angle may be named using simply its vertex. That's the last one here. So the B is in the middle in each designation. For the first 2 exercises, we are to name the angle in 5 different ways. So let's see, for number 1, we know that the rays are ED and EF, and this is the angle E. Therefore, we can write angle DEF or angle FED, or we use the angle symbol DEF, angle FED, or simply angle E. And for number 2, it's very similar. the ray is QF, QP, and QR, and the angle is at Q. So we write angle PQR or angle RQP or we use the angle symbol, angle PQR, or angle RQP. Or simply angle Q. Now, to measure angles, there's a device called a protractor. And they have two scales, one on the inside, one on the outside. So here's the inside scale from 0, 10, and so on, all the way up to 180. And the outside one goes from 0, 10, 20, 30, etc. to 180 over here. So to measure an angle like Q, angle Q that we talked about just a moment ago, we place a protractor's triangle at the vertex and line up one of the angled sides at 0. So here's 0, and there was the ray QR. And then we check where the angle's other side crosses the scale. So there was the other ray from Q to P. And we can see that this lines up with 145, between 140 and 150, that's 145 degrees. So QR lines up with 0 on the inside scale, and so we check on the inside here, and again that's 145 degrees for the measure of the angle Q. Use a protractor to measure this angle. I use the protractor, and it turns out the angle has a degree measure of 127 degrees. Similarly, when we use a protractor to measure this angle here, that turns out to be 33 degrees. Next, we'll be classifying angles, and they're right angles, and a right angle has a measure of 90 degrees. A straight angle is an angle whose measure is 180 degrees. An acute angle is an angle whose measure is greater than 0 and less than 90 degrees. An obtuse angle is an angle whose measure is greater than 90 degrees and less than 180 degrees. So these are vocabulary words, and that means you need to remember what they mean. So we're going to do some exercises here. Classify each angle as right, straight, acute, or obtuse. Well, number 6 is greater than 0 degrees and less than 90 degrees. So it's an acute angle. Number 7, this angle is certainly greater than 90 degrees, but less than 180 degrees, so it's an obtuse angle. Then the complementary angles. Two angles are complementary if the sum of their measures is 90 degrees, and each angle is called a complement of the other. So in exercise 9, we're asked to identify each pair of complementary angles. Since angle 1 and angle 2 equals 90 degrees, angle 1 and angle 2 are complementary angles. And then angle 2 and angle 3, 35 plus 55 is also 90 degrees. So angle 2 and angle 3. And then angle 3 and angle 4 also add up to 90 degrees. So angle 3 and angle 4. And then angle 1 and angle 4 also add up to 90 degrees. So angle 1 and angle 4. So we have 4 pairs of complementary angles. So in these exercises, we have to find the measure of the complement of each angle. And so let me just give you the general idea. So for number 10, we know that the complement of the angle we are looking for, let's say C, angle C plus 45 degrees has to equal 90 degrees. So subtracting 45 from both sides tells us that the complement angle is 45 degrees. Again, you can check 45 plus 45 is 45 degrees plus 45 degrees is 90 degrees. And we can do the same, we can use the same approach for number 11. The complementary angle plus 18 degrees must equal 90 degrees. Subtracting 18 on both sides gives us C, the complementary angle, is 72 degrees. And for number 12, it is C plus 85 degrees equals 90 degrees. Subtracting 85 on both sides tells us that the complementary angle is equal to 5 degrees. So the answer here is 45 degrees. The answer here is 72 degrees. And the answer here is 5 degrees. So then we have a guided solution, and that is since the complementary angle and the given angle is equal to 90 degrees, then 90 minus 67 is equal to 23 degrees. The next topic are supplementary angles, and the two angles are supplementary if the sum of their measures is equal to 180 degrees. And each angle is called a supplement of the other. So make sure you remember the difference between complementary angles and supplementary angles. So number 14, we are to identify each pair of supplementary angles. Since angles 1 and 2 form a straight line, angle 1 and angle 2 are supplementary. Angle 3 and angle 2 and angle 3 are supplementary. Angle 3 and angle 4 and angle 4 and angle 1. For the next 3 exercises, we are finding the measure of a supplement for each angle. So for number 15 would be 180 minus 38 equals 142 degrees. So here the answer is 142 degrees. Number 16, 180 degrees minus 157 degrees is equal to 23 degrees. So here the answer is 23 degrees. And for number 17, 180 degrees minus 90 degrees is equal to 90 degrees. So 90 degrees is the answer. And then for the guided solution, for 71 degrees, the supplement is 180 minus 71, and that's equal to 109 degrees. So again, the equilateral triangles have all sides with the same length. An isosceles triangle has 2 or more sides that are the same length. And in a scalene triangle, all sides are of different lengths. A right triangle has one angle that is a right angle. An obtuse triangle is an angle that is an obtuse angle, has an obtuse angle. And an acute triangle means that all 3 angles are acute. Again, these are vocabulary words, and you may want to commit them to memory. So you have to look up the meaning every time the words come up. So when we look at the triangles that we just seen the different shapes of, so the question is, which ones are equilateral, which ones are isosceles, and which ones are scalene? The first question was, which triangles are equilateral? Well, since the lengths of the sides are given, there's only one of them that has 3 equal sides, and that's triangle ABC. So equilateral triangle ABC. Then isosceles means 2 or more sides are the same. So let's look at that. And so we see that in this triangle here, triangle MPN, 2 sides are the same. But also note that the triangle ABC has 2 equal sides. So in other words, there are 2 isosceles triangles here. One of them is again triangle ABC and triangle MPN. then scalene, remember that means all sides of different lengths. And so scalene means each side is different. So we see that DEF has different sides, all sides are different. So triangle DEF. And then the other one is GHI, the sides are all different. Triangle GHI. And triangle JKL, all the sides are different. Triangle JKL. And then the last one here, triangle QRS, has different side lengths, so that's another one. Triangle QRS. So here are the answers that I wrote down for you. So there's one equilateral triangle, 2 isosceles triangles, and 4 scalene triangles. Number 20 asks, are all equilateral triangles isosceles? Well, again, isosceles triangle means 2 or more sides of the same length, so that means the answer is yes. Then the question for number 21 is, are all isosceles triangles equilateral? No, for a triangle to be isosceles, it needs 2 sides that is the same length. So that answer is no. So in 22a, the question is, which of these triangles are right triangles? Well, there's only one here with a right angle, so that's triangle DEF. DEF. And then obtuse triangles, there's one of them here, triangle GHI, triangle GHI, and also the triangle here, triangle QRS. Triangle QRS is an obtuse triangle. And what are the acute triangles for the last question here? Well, triangle ABC, triangle ABC is an acute triangle. Triangle MPN, this one here, triangle MPN, and then triangle JKI, and that's it for the acute triangles. Next is a very, very important statement, so be sure you remember that. In any triangle ABC, the sum of the measures of the angle is 180 degrees. This is really, really important to remember. So it's the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So here we have a triangle, PQR, and the question is, find the sum of measure of angle P plus the measure of angle Q plus the measure of angle R. So we know the sum of these is equal to 180 degrees. Because it's true for any triangle. Now, in number 24, we are supposed to find the missing angle measure. So now we're making use of the same formula. So the measure of angle A plus the measure of angle B plus the measure of angle C, X rather, equals 180 degrees. Since the measure of angle A is 55 degrees and the measure of angle B is 61 degrees, and now with the measure of angle X, this equals 180 degrees. So in other words, we have an equation with one unknown, X. We know the other two terms here. So then the measure of angle X is equal to 180 degrees minus 55 degrees minus 61 degrees. So the measure of angle X is equal to 64 degrees. And this is the end of section 9.5. In section 9.6, we're discussing square roots and the Pythagorean theorem. And you may have heard of both subjects before, or both topics, square roots and the Pythagorean theorem. So for some of you, this may just be a review, but for some of you, maybe there's some new material for you. First of all, what's a square root? Well, if a number is a product of two identical factors, then either factor is called a square root of the number. So if a equals c squared, then c is the square root of a. And this symbol here is called the radical sign and is used in naming a square root. So again, I'm pretty sure you've seen this symbol before, the radical sign. So how does it work? So here we're supposed to find the square. So 9 squared is equal to 9 times 9, or 81. 10 squared is 10 times 10, or 100. Let me just put a box around it to indicate the solution. And 15 squared is 15 times 15, or 225. And 16 times 16 is 256. So then 11 squared is equal to 11 times 11, or 121. And 12 squared is 12 times 12, or 144. And 17 squared is 17 times 17, which is 289. And 18 squared is 18 times 18, and that's equal to 324. Then for the next row, 13 squared is 13 times 13, or 169. 14 squared means 14 times 14, which is 196. And 20 squared is 20 times 20, or 400. And 25 squared is 25 times 25, or 625. For these exercises here, to simplify, we can use the results of the previous exercises. That may be helpful. So to find the square root of 9, we're asking ourselves which number multiplied by itself equals 9. Well, 3. Because 3 squared equals 9. Then the square root of 16, we ask which number multiplied by itself equals 16. And that, of course, is 4, because 4 times 4 is 16. And number 15, if we go by the numbers here, the square root of 121. So which number multiplied by itself equals 121? Well, 11, because 11 squared equals 121. And the square root of 100, which number multiplied by itself gives us 100? Well, that's 10. 10 times 10 equals 100. And here, which number multiplied by itself is 81? Well, 9, because 9 times 9, or 9 squared, equals 81. And which number multiplied by itself is 64? 8, because 8 times 8, or 8 squared, equals 64. Similarly, the square root of 324, which number multiplied by itself equals 324. If you look at the previous exercise, you find that 18 squared is 324, so the square root of 324 is 18, because 18 squared equals 324. And the square root of 400, so which number multiplied by itself is 200? Well, again, from the previous exercise, we know that 20 times 20 is 400, so therefore the square root of 400 is 20. And which number multiplied by itself is 225? Again, the previous exercise showed us that 15 squared equals 225. Therefore, the square root of 225 is 15. Because 15 times 15 equals 225. Here the square root of 169. We asked which number multiplied by itself equals 169. From the previous exercise, we know that 13 squared equals 169, so 13 is the answer. Now here's some easy ones. The square root of 1 is 1, because 1 times 1 equals 1. And the square root of 0 equals 0, because 0 times 0 equals 0. So if you look at the previous exercises, you note that all the solutions are whole numbers. But that's not always the case. And so we use what's called decimal approximations to square roots, and we can find them using a calculator. So use a calculator to approximate to 3 decimal places. So to use a calculator to approximate the square roots to 3 decimal places, let's look at an example. So here's my calculator, and I input the number 5, and then I touch the square root button here, this one here, and here's the answer. And then to 3 decimal places, the answer is 2.236. And remember, that's an approximation. It's not an exact number. And square root of 78, it's the same thing. We input the number 78, and we touch the square root symbol here. And the answer is 2.9718. So so the answer is 8.8317, so we round this to 8.832.
Me, I cannot believe this. This max was on the second step. It's ridiculous. Ridiculous.
Where does this come from?
Kaiser Eras, Rosary. So later we'll check what is this. I'm sorry to bother you.
That's okay.
Of course,
Oh, I know what that is.
What is that?
That's a pre-surgery kit.
Oh, okay. But it was there and the UPS delivered it on the steps.
That's stupid.
Totally.
I mean, that is...
Sorry to bother you.
No, it's okay.
I was already driving and I saw the box.
Yeah.
Okay, fine.
To discuss the Pythagorean theorem, we look at a right triangle, in other words, a triangle with a 90-degree angle, right here. And in a right triangle, the longest side is called the hypotenuse. And it is the side opposite of the right angle. The other two sides are called legs. Leg A and leg B, typical letters for the length of the legs. And C is called the length, typically the length of the hypotenuse. And here's how the three quantities are related. In any right triangle, if A and B are the lengths of the legs and C is the length of the hypotenuse, then A squared plus B squared equals C squared. In other words, leg squared plus other leg squared equals hypotenuse squared. The equation A squared plus B squared equals C squared is called the Pythagorean equation. In the guided solution exercise number 29, we are supposed to find the length of the hypotenuse in this right triangle. Using the Pythagorean equation, A squared plus B squared equals C squared, 12 squared plus 5 squared equals C squared. So, and since 5 squared is equal to 25, we have 144 plus 25 equals C squared, and 144 plus 125 is 169, is equal to C squared. So now what is C equal to? Well, C is a number which multiplied by itself is equal to 169, and that of course is 13. So the length of the hypotenuse is 13 units long. So for number 30, we have a right triangle with hypotenuse 14 and legs A and leg 11 units long. The right triangle is right here. The right 90-degree angle is here. So, using the Pythagorean equation of A squared plus B squared equals C squared, we then have A squared plus 11 squared equals C squared, or 14 squared, or A squared plus 121 equals 196, because 14 squared is 196. So then A squared is equal to 196 minus 121, that's 75. So the exact solution is A equals the square root of 75. And when we use a calculator to approximate the square root of 75, then A is approximately equal to 8.660. So this is the exact solution, and this is the approximation. Number 31, we use the same approach. A squared plus B squared equals C squared. So here we have one of the legs is 1, the other one is B. So let's say A, this would be leg A. So 1 squared plus B squared equals 11 squared, the hypotenuse. Again, remember the hypotenuse is opposite from the 90-degree angle. So this then is equal to 1 plus B squared equals 121. And when we subtract 1 on both sides, then B squared equals 120. So the exact solution is B equals the square root of 120. and the approximation b is approximately equal to 10.954. Again, this is the approximation, and this is the exact solution. And for number 32, again we use the Pythagorean equation, a squared plus b squared equals c squared. So here's a, so a squared. Here's the other leg b plus 15 squared equals c squared, the hypotenuse squared, or 20 squared. So a squared plus 15 squared is 225, and 20 squared is equal to 400. Subtracting 225 on both sides, a squared is then equal to 175. Therefore, a equals the square root of 175. That's our exact solution. And the approximate solution, a is approximately equal to 13.229. Again, we get the approximation by using a calculator, as we have done in some of the previous exercises, where we calculated the approximation to the square root to 3 decimals. As an application to the Pythagorean theorem, we have a word problem here. And so here the question is, how long is a guy wire reaching from the top of an 18-foot pole to a point on the ground 10 feet from the pole? Give an exact answer and an approximation to our nearest tenth of a foot. So here's what it looks like. Our right angle is here. Here are the two legs, 18 feet and 10 feet. And we need to calculate how long the hypotenuse is. Again, using the Pythagorean equation, a squared plus b squared equals c squared. So a is, say, that's this one, 18 squared plus 10 squared equals c squared. 18 squared is 324, and 10 squared is equal to 100, so that's equal to c squared, or 424 equals c squared. And so now, to find out how long the wire is, we need to find c. So c then is equal to the square root of 424, and that of course is feet. And that's the exact solution. Then the other question was, find an approximation to the nearest tenth of a foot. So then we're using a calculator for the square root of 424. C is approximately equal to 20.6 feet. So the Pythagorean theorem can come in many different forms, and many different applications, I should say, but it's quite useful. In fact, the use of the Pythagorean theorem goes back thousands of years, and Pythagoras was a very famous mathematician from antiquity, and so this formula has been used many, many times. So this is the end of section 9.6, and this is also the end of chapter 9.